Hey Algebra 1, we are going to work on lesson 12 today, which is solving equations. You should be able to follow along in your classwork. I go over it exactly in the order you have it. I may skip a few things, but everything will be there for you to follow along. I expect you to write the answers down in your classwork so that you can go back and review if you need to. First off, our opening exercise, we're going to answer the following questions. First of all, why should the equations x minus 1 times x plus 3 equal 17 plus x, and x minus 1 times x plus 3 equal x plus 17 have the same solution? We learned about the commutative property earlier in the unit. The commutative property of addition. All we did here was take this part and flip them around in a different order. Next question, why should the equations x minus 1 times x plus 3 equal 17 plus x, and x plus 3 times x minus 1 equals 17 plus x? We have the same reasoning right there. The commutative property of addition. Not addition, sorry, multiplication. All we did here is flip the order of these. Everything else is the same. Next question, do you think the equations x minus 1 times x plus 3 equals 17 plus x, and x minus 1 times x plus 3 equals 500, x minus 1 times x plus 3 plus 500 equals 517 plus x? Do you think they should have the same solution set? Yeah, the only thing that we did different is we added 500 to the left side of the equal sign, and we added 500 to the right side of the equal sign, which gave the left side to be this, and the right side to be 517 plus x. So yeah, if we do something to both sides of the equal sign, then our equation hasn't actually changed, and we would get the same solution set. D, do you think the equations x minus 1 times x plus 3 equals 17 plus x, and 3 times the quantity equals 51 times 3x have the same solution set? If I do 17 times 3, I get 51. So all I did here was multiply the left by 3 and the right by 3. So yes, we should get the same. Okay, let's move into our first exercise. Use the commutative property to write an equation that has the same solution set as given. So the commutative property means that I'm going to rearrange a few things, right? Let's see. If I do negative 3x plus x squared plus 4, I just rearranged it. X plus 7, rearrange this one, 5, and x minus 12. Those have the same solution set because all I did was rearrange the equations. I didn't change anything. Use the associative property to write an equation that has the same solution set. Okay, associative property, I'm just going to group things a little bit differently. Let's just group that, and that works. And then that would be the same equation as the original one. So you could just rewrite your equation with those first two monomials, or those first two terms grouped. Does this reasoning apply to the distributive property as well? Yes, it does. It applies to the distributive property, the associative property, and the commutative property. Cool. Okay, all we've done here is a few different rules. If I have A equals B, I can also have A plus C equals B plus C. And that's true for all numbers C. These are both true statements. I could also say if A is not equal to B, then A plus C is not going to be equal to B plus C. right? All right, let's see, what else can I tell you? Thinking. I could do multiplication. If I have A equals B, I can do A times C equals B times C. That's true. Even if I have A is not equal to B, that means A times C is not going to be equal to B times C, right? Multiplication works the same. Cool, let's move on. All right, consider the equation x squared plus 1 equals 7 minus x. Verify that this has the solution set of -3, 2. Draw the solution set as a graph on the number line. We will later learn how to show that these happen to be the only solutions to this equation. So on the left here, I've substituted x equals -3 into the equation, and let's go ahead and solve it. I have -3 squared plus 1. This would be 9 plus 1, which is 10. Yikes. Is equal to 7 plus 3, which is 10. When 10 equals 10, that means it's a true statement. And then over to the right, 2 squared is 4, plus 1 is 5, and then 7 minus 2 is 5. So that is also a true statement. If I drew this on a number line, I would have -4, -3, -2, -1, 0, 1, 2, 3. And I would go ahead and put a closed dot at -3 and a closed dot at 2 to show my solution set. Okay, let's add 4 to both sides of the equation and consider the new equation, x squared. Well, let's just go ahead and do it. X squared plus 1 equals 7 minus x. I'm going to add 4 to both sides. X squared plus 5 equals 11 minus x. Verify 2 and -3 are still solutions. So -3 squared plus 5 is 9 plus 5, which is 14. Then I have 11 minus a -3, which is also 14. It works. Then I can go ahead and do 2 squared plus 5 equals 11 minus 2. 4 plus 5 is 9. 11 minus 2 is also 9. So I just verified it. All right, let's take that equation again and add x to both sides. And we'll get the new equation, x squared plus 5 plus x equals 11. And let's verify 2 and -3 again. Start with -3 squared plus 5 plus -3 equals 11. I get 9 plus 5 is 14, minus 3 is 11. We got it. Now 2 squared plus 5 plus 2 equals 11. 4 plus 5 is 9, plus 2 is 11. And it works. Okay, going back to that equation on the previous slide, let's add -5 to both sides of the equation. So I'm grabbing this equation and I'm adding -5 to both sides. I have x squared plus x equals, that would be a -5, sorry, 6. We're still going to verify 2 and -3. -3 squared plus -3 equals 6. 9 minus 3 does in fact equal 6. 2 squared plus 2 equals 6. I have 4 plus 2 does in fact equal 6. All right, almost done. Let's multiply both sides by 1/6. So I've got x squared plus x equals 6. I'm going to multiply everything by 1/6, multiply that through. X squared plus x over 6 equals, so I just went to this, and it's that last one, 1/6 times 6 is 1. Go ahead and substitute -3. Oops. Negative 3 squared plus negative 3 over 6 equals 1. 9 minus 3 is 6. Does in fact equal 1. And then substitute 2 squared plus 2 over 6 equals 1. 4 plus 2 is 6. Over 6 equals 1. All right, let's go back to part D, which is just above, and add 3x to the third power to both sides of the equation and consider the new equation. So we have x squared plus x plus 3x cubed equals 6 plus 3x cubed. Let's go ahead and test into our 2 and negative 3. Negative 3 squared plus negative 3 plus 3 times negative 3 cubed. 6 plus 3 times negative 3 cubed. 9 minus 3, negative 3 cubed is negative 27. Nine minus 3 minus 81. You get negative 75. And that equals 6 plus 3 times negative 27. 6 minus 81. They both equal 75. Let's try 2. 2 squared plus 2 plus 3 times 2 cubed equals 6 plus 3 times 2 cubed. 4 plus 2 plus 3 times 8. 6 plus 3 times 8. I get 6 plus 24 equals 6 plus 24. 30 does in fact equal 30, so both work. Yes, they're both still solutions. So it's important to point out when we worked through A through E, those were all different things that we could do to an equation. We added something to both sides, we subtracted something from both sides, we multiplied both sides by a number. Those are all things that we can do to an equation, and the solution set held true. No matter what we do, if we change an algebraic equation, the left and the right side of the equal sign, if we change it equally, then our solution set always holds true. All right, these last 2 pages just go through a few examples. This is what your homework is going to be like. So I'm just going to go through the answers. For this, I always just multiply down. It's almost like a ratio equals a ratio. If I have 3 times 4 is 12, 1 times 2r is 2r, divide both sides by 2, I get r equals 6. So my solution set is, in fact, 6. Right, this next one, I get that variable by itself, so I'm going to subtract 5 from both sides, and I'm left with s squared equals 25. I take the square root of both sides, and I get s equals positive or negative 5. And my solution set looks just like that. Finally, I'm trying to solve for y, so I'm trying to get y all by itself. I'm going to subtract 4y from both sides. I'm left with negative 3 equals y minus 8. Add 8 to both sides. Y equals 5. And we see our solution set. That's beautiful squiggly, isn't it? And last but not least, a few more examples. If we consider the equation given, there's lots of different ways you can solve this equation. And we're going to try different ways. So for this first group, I'm going to subtract 3x from both sides first, and then solve it. I'm left with 4 equals 5x minus 16. Add 16 to both sides. 5x equals 20. Divide both sides by 5. I have x equals 4. Or we can start by the first thing we do is subtract 4 from both sides. Oh, goodness. There's the problem. I was very confused there. I wrote down the wrong problem. There we go. Subtract 4 from both sides. 3x equals 8x minus 20. Subtract 8x from both sides because I need that variable to be by itself. Negative 5x equals negative 20. I'm going to divide by negative 5. I'm left with x equals positive 4. Two other different ways to do it. Start with the same equation. This first time I'm going to subtract 8x from both sides. Left with negative 5x. Subtract 4 from both sides because I'm trying to get that variable by itself. And divide both sides by negative 5. I got the same answer. Okay, last way to try this. I need to, sorry, one second. Add 16 to both sides of the equal sign. And then I'm going to subtract 3x. I always like it when my variables end up positive as I'm working. There we go. Okay, 4 different ways to work the same problem. On our homework tonight, we're going to practice solving equations. Right, it doesn't matter which way you start, as long as you follow the rules of algebra. What you do to the left-hand side, you have to do to the right-hand side. Good job.